Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. How is the world of science going on?
I saw quite a nice little story this week.
Yeah.
A guy called Jan Henning Dirks, who's actually based here in Cambridge, has been studying insects. Have you ever noticed the way insects can climb almost anything? Also climb up walls and over the top of ceilings and back down again?
Yes.
He's been studying about why they can do it. And it seems it's actually to do with their feet. And quite a lot of insects can stick to things because their feet exude a kind of emulsion. This is a bit like mayonnaise, so a mixture of oily stuff and watery stuff.
Right.
Little droplets. They exude it. And then if they're sticking onto something which is attracted to water, then the water sticks to and then they'll stick to the water. Mm-hmm. If they're sticking onto something hydrophobic, which doesn't like water, then the oil will stick to it. And they've got this little layer and they keep exuding it and they can stick to almost anything. And while he was doing the experiments, he had a play and he managed to find a material which would suck the water out of this emulsion, as far as I can tell. And therefore you've only got the oil, and oil's quite a good quite a good lubricant. So all of a sudden their feet go from being entirely slippy to quite well lubricated. Mm-hmm. So if they try and climb up this stuff, they slide back down. And this would be really brilliant because all over the world, particularly less so in this country, but particularly in hot places, you have huge problems with things like cockroaches and termites, which will climb up anything and then eat all your food, or with termites eat your house. So they've come up with this material which you can sort of, if you make a column out of it, insects can't climb it. It's less sticky than PTFE, less sticky than Teflon. And insects can climb Teflon quite happily, but they can't climb this stuff.
Really?
So it might be wonderful for people living in countries where their houses keep getting eaten. You just build it on stilts and cover the stilts with this stuff. And the insects will just keep falling off.
Thing is, though, they could evolve themselves, couldn't they? If they've evolved themselves to be able to get on some Teflon, mate, they could evolve themselves. Depends
how long they've got, I think.
Yeah. So, our first one, Dr. Dave, is this one. Says Ralph in Stanford. Question for Naked Science. In the Isle of Wight, there is an area of a beach with multicoloured sand. How do they do this? Is it dye or something? And also, why isn't there more of this done at different resorts? Interesting. I don't know how they work that out. Dave?
Yeah. I think what he's talking about is a bay on the Isle of Wight called Alum Bay. And if you look at the cliff above it, over sort of 200 or 300 metres, there's about sort of lots and lots of different colours of sand. It's basically lots of layers. It was originally laid down flat, so you'd have a layer. It was originally laid down in a tropical delta, so you'd have sometimes you'd have a river running over the top of it, and it would deposit some mud. And other times there wouldn't be a river there at all, and you'd have some beach sand. And other times it would sort of grow a little mangrove swamp, and it would make a bit of coal. And then over millions of years it's all got rotated by 90 degrees, so it was originally all horizontal, and it's been rotated, so it's all lying vertically now. And it just so happens that at a different time, sometimes the river maybe flooded and was eroding lots of stuff in it from air with lots of iron in it, so lots of iron came down, and so you get a really reddy, rusty layer of sand. Other places they was eroding stuff from somewhere else, or the beach was bringing in very pure silica, so you get from very white sands, and it's just entirely natural, and you got lots of different sands in the cliff.
We're going to go to the phones in just a little while. Mike in Colchester says, inkjet printers, how do they deliver such a vast array of colours from one cartridge? And so quickly too.
They are very impressive things, inkjet printers. Inkjet printer basically works by squirting little tiny blobs, little drops of ink out of a cartridge. They can either squirt them by having a little piezo cell which squashes it and actually literally squirts some ink out. Otherwise you get bubble jet printers which boil some ink and that blows a little droplet out. But basically they're all putting little droplets of ink in. They all have... Most inkjet printers have 4 different colours of ink. They've got black, and they've got yellow, cyan and magenta. And these are the three primary colours of printing. There are the three primary colours of light, which are red, green and blue, which if you look very closely up against your TV, you can see little blobs of red, little blobs of green, little blobs of blue.
Bit like me tonight, Dave.
There's a lot of green there, but...
Yeah.
Anyway, yeah, and because your eyes have only got three sensors, one of them which is mostly sensitive to blue light, and another two which are sensitive to red and green lights. It's actually always more complicated than this. But basically, you can fool your eye into thinking it's seen any colours by mixing red, green, and blue light. Yeah. Okay, so TV works by just giving out red, green and blue light. If you're printing, you're not emitting light, you're absorbing light. So to make all the colours that you can see, you want one kind of ink which absorbs red light, which is a sort of turquoisey colour because it gives out green and blue. You want one which will absorb green light, which is a sort of mauvey colour called magenta, and another one which will absorb blue light, which is yellow. So if you mix those together, you can absorb any different selections of light you like, and then you can see whatever colour you like. And then you add black to change how light and dark it wants to look. So just because of the way your eyes work, it's quite easy to fool them.
Right, Mike, I hope that's sorted your question out. All right, OK, we've got phones now, so let's go to Tony. Hello, Tony. What's your question?
Well, when I was very young at my house, we had a strange system for lighting, and if you went over about, I suppose it would be about a kilowatt, they used to flicker. Everything flickered. And it was very cheap. I think it was £3 a year, the electricity. But I just wondered if today they could do something like that, perhaps with more of a buzz or...
Yeah, so you'd know when you're using lots of... So
exactly.
It was basically to tell you when you're using too much power.
Yeah, something like that. Or you could even set it so it would buzz at a kilowatt, 2 kilowatt, 3. Has anybody done anything like that?
You couldn't really make the electricity turn on and off and flicker because it would cause... Any electronics would go absolutely crazy.
Oh, no, that's why I say we couldn't do it anymore like that. We could make a buzz or...
Yeah. Definitely the government, I think, is trying to encourage people, or definitely encourage the power companies to install what are known as smart meters, which will tell you how much power you're using. So you can go and look at them and they have a display on them, and it will tell you how much power you're using at the moment and how much power you've used over the last day, over the last week and things. So if you're at all interested, and there's no reason why you couldn't set it to buzz, but I think you're really more interested in how much power you're using over a day rather than how much power you're using for an individual second. Because a kettle uses a huge amount of power, and if you used a shower, they use something like 7 kilowatts in electric. So they're going to, although you might not be using it for very long, so it's always going to buzz when you take it. If you make it so it doesn't buzz for the electric shower, it's not going to detect anything else either.
It's better to have a bath then.
But yeah, but definitely knowing what uses lots of electricity is very, very useful.
It's a wonderful idea, actually. Yeah.
So, yeah, I think they're definitely attempting to bully the power companies into installing them over the next few years.
Yeah, you see, we've gone from that little slow wheel, haven't we, to a flashing whizzy light. Yeah, better to have a bath then, Tony.
Oh, lovely. I like a good bath.
Me too. Take care. Bye-bye.
And you do. Bye.
Bye-bye. Right, Keith says, why do heavy iron ships float? What is the method to keep them buoyant?
The simple answer is because they're full of air. For something to float, it's got to be basically it's got to the amount of water it pushes out the way when it's sitting in the water has got to weigh more than the object itself. Mm-hmm. So if you've got iron, because it's very dense, it weighs a lot for its volume. Maybe a cubic metre of iron weighs about 5 tons, but if you put it in water, it will only push out of the way 1 ton of water. But if you hollow out that cubic metre of iron, and then you can take out 4.5 of the tons of the iron from the middle and fill it with air, which is very, very light, so hardly weighs anything, then you've got something which weighs 0.5 ton, but still could displace a cubic metre of water, which weighs 1 ton, and so therefore it will float. If you let the water in the middle, then it's not displacing nearly as much water, and it will sink. So if you knock a hole in the side of a ship, it will sink. Actually, wooden ships will sink as well if you knock a hole in the side, because they've normally got lots of ballast in the bottom, lots of stones and things to keep them stable. And so wooden ships they'll sink perfectly well if you knock a hole in the side and let the water in as well.
Hazel's called in, and she says when she makes jam or preserves, you get a lot of bubbles come up, and when you bring it to the boil, but when you put a knob of butter in, it stops it bubbling. Why is this?
That's a very, very good question. I don't know.
He doesn't know.
There's a couple of things which it might be, although I don't know how big the effect is. One of them is that the butter's quite cold, but I imagine you're not going to put that much butter in. It's not going to significantly cool it down. Another thing might be that the butter could have quite a lot of dissolved. I don't know whether she's putting the knob of butter in while it's boiling and it suddenly starts boiling, or whether it didn't boil in the first place.
Would it not be the change in temperature, though?
I mean, it could be reducing the temperature of everything a bit, but there's not very much butter there, and it's probably not going to seriously affect the. Is it making bubbles on the surface?
Yes, I suppose it must be.
Sorry, I'm attempting to work out what's going on.
Yeah, bit of kitchen science coming up here.
It's sort of stopping it foaming.
Yeah.
Butter's got all sorts of. It's got lots and lots of calcium in it. Milk's got lots of calcium in it. I'm working it out.
Right.
Okay, the reason why it's going to be bubbling is because you get things called surfactants almost in your body. These are like washing up liquid. In fact, all your cells are made up of basically little bubbles of water with 2 layers of surfactant, 2 layers of washing up liquid, incredibly thin, only 1 molecule thick, making a bag. These will also make things bubble, so they can form big bubbles as well as small bubbles of cells. And therefore, if you've got lots of them because you've mashed up, there'll be lots of them in the cells of the strawberries, whatever you've made the jam from. And if you mash up all these strawberries, there'll be lots of surfactants in there, so it's like having some washing up liquid in there.
Right.
And what I think probably the butter is doing is, in the same way as hard water doesn't foam as well as soft water, and also if you've got lots of oily stuff in washing up liquid, it stops in your washing up water.
Yeah.
All of the surfactants, all washing up liquid is used up trapping all that oil, and none of it's left on the surface to make a foam. So if you put oily butter into your jam, then all of these surfactants will be used up, kind of forming little globules of oil and dissolving the oil, and there won't be any left to make foam. So the jam will stop foaming.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast. Let's press on with questions now, because we have one here, which Jeff in Ipswich, Dave, has asked us by email. When your electrics at home trips out to Earth, why does it not affect your neighbour's supply?
The way it detects whether you've tripped out to Earth or whether there's electricity flowing to Earth is that into your house there's 2 wires, one which electricity comes in on, and another one which the live, another one which it goes out on. Actually, it's flowing backwards and forwards, but the current going through one of them should always be exactly the opposite of the current going through. The current going through the live should always be exactly the same but opposite as the current going through the neutral. And your trip switch measures those 2 currents and measures the difference between them. And if that difference gets more than, I think probably a few microamps, definitely a few milliamps, tiny amount, it decides that there's current flowing, escaping somewhere. It could be escaping through you, so it turns it off very quickly. Or it could be escaping to something which could cause a fire, so it turns the power off. So each trip switch is measuring the current going into your house and the current going out of the house. And your neighbours will have one which does exactly the same. But the current, and there will be a very big one on the mains supply, but that will be not very sensitive at all. That's not designed to stop people killing themselves. That's just to stop the power supplies blowing up trees and using up too much electricity. So the trip switch will only it's only the difference between the current going in and out of your house. So it won't affect your neighbours at all.
Right, I hope that's answered your question. Charles in Buckton says he's read that global warming could be cheaply reversed by pumping sulphur dioxide into the upper atmosphere. Is this feasible?
Certainly, sulfate particles can cool the environment. It's thought that pollution, which when lots of coal throws lots of sulphur up high into the air, that forms lots of little particles high in the air, and they tend to reflect the sunlight and cool down the area underneath them. And that might be part of the reason why the world actually got really quite cold, particularly Europe got cold during the end of the 19th century, first half of the 20th century. You got lots of nice, really cold winters when it should have been warmer because there was all of these sulfate particles in the air reflecting sunlight. You get the same effect from big volcanoes. They can throw sulfate particles up into the stratosphere, tiny, tiny particles, and they can reflect sunlight and cool down the area under them, basically puts it in a big shadow. It could do that, and it might buy you a little bit of time from global warming, but it would probably also produce all sorts of other climactic change, because if you suddenly make less sun getting to one area, that's going to make one area cold. That could entirely reroute lots of winds, and it could make some areas dry which used to be wet, and make some areas wet which used to be dry, which is actually the real worry with global warming. It's not so much that a world which is a little bit warmer, it would be a big problem. If the world was a lot warmer, it would certainly be a problem. If the world's a couple of degrees centigrade warmer, it wouldn't be a huge problem for us, apart from the fact that all of the lovely fertile areas where lots of people live at the moment some of them are going to become infertile, and other areas which are now very infertile are going to become fertile. And that means that all the people are going to be living in the wrong place, and it's going to cause all sorts of huge kind of societal problems. And it's going to cost billions and billions of pounds, probably trillions of pounds, sort of moving the infrastructure around. And so it might cause more problems than it solves.
It definitely would do, I think so. Hello to Dave in Great Yarmouth, who sent an email in to say, Dear Dr. Dave, I remember as a child there were articles in the newspapers in the 1970s that mentioned about water-powered, hydrogen-driven car patents being brought out by the Arabs and the car giants. I know we have water-powered cars being produced on a very small scale and small in some parts of the world today, but surely even by today's standards, these would be outdated. Why has every other technology advanced beyond recognition, but we are still driving around in piston-driven engines developed over 100 years ago? It's tradition, Dave. That's what I reckon. What do you say?
There's two things. One of them, definitely hydrogen-powered cars can work. You can produce the hydrogen by splitting water, although most hydrogen these days is actually produced by splitting natural gas, which is slightly less useful because that also produces global warming. So if you wanted to produce all the hydrogen by splitting water, you'd need an incredible increase in our electricity generating power. And if we generate that using fossil fuels, we haven't actually gained very much. So you'd need to build an immense number of wind turbines or a huge amount of tidal power. We'd have to sort out solar power and make it cheap enough to be economic. And basically, it's a difficult technology. I mean, even just storing hydrogen is very difficult. It's a gas. It doesn't form a liquid very easily until you get to really ridiculous pressures. So it's very dangerous. It's also very explosive. So just dealing with it is very dangerous. He might also be... I mean, there's definitely lots of stories which apparently someone has built a car which works on just straight water. And I've never heard of one of those which actually, when someone looks at it properly, would actually work and actually generate power. They tend to either be someone either fooling themselves into thinking they've built a car which is powered by water, or trying to fool other people.
Simon has called in, and he says, how old is the water that comes out of the taps?
It will depend a lot on where you live. Most of this area, the water would have been got by sucking it out of chalk aquifers. This is basically chalk's got lots of gaps in it. When it rains, water kind of percolates down through the soil and into the rock, and you end up with a large amount of sort of water sitting around in the aquifer, just kind of in the holes in the rock. And then if you drill a hole and suck, you can get water out. It's basically the principle of a well. And people have tried to get some idea of how old the water is by looking at substances mixed in it for very small amounts of things like chlorofluorocarbons, the CFCs, which are really bad for the ozone layer, which are only made by people, and things like sulfur hexafluoride, again, which are only made by people. And looking for amounts of those in the water. They reckon that the water in this part of the country is maybe a few decades old, the stuff which you're drinking. I guess because you tend to be sucking it out of the top of the aquifer, and it's only recharged into the top of the aquifer, so a few decades old. If you had lived in the west of the UK, then most of the water comes straight off places like the Lake District or Dartmoor into a dam, comes down a river into a dam. It might get stored there for at the most a year or two, but it could be much younger than that. It could almost be kind of a few months old.
Wow.
If you live in bits of the Sahara, it can be tens of thousands of years old. You get rain tens of thousands of years ago. It can build up underground, and in fact, then it can bubble up the surface in the form in oases. And that's really kind of worrying, because if people are pumping that out quickly, it's not going to get replenished anytime soon. So once it's run out, it's run out. So you're essentially just mining it.
Wow, interesting stuff. Hello to Patrick in Felixstowe. Question: why don't they use sugar to produce alcohol to run cars? We have so many dormant fields in this country. Why don't we use them and go back to the idea of multi-fuel engines?
Simple answer is they do. A lot of the fuel in Brazil is manufactured from sugar cane. And they ferment up the sugar cane, and then they distill it, and you get very high purity alcohol. You've got to get it you've got to get almost all the water out of the alcohol, otherwise it won't mix with petrol. So if you have alcohol in your car one day, then petrol in the other one, they won't mix, and that causes all sorts of problems with the pumps and things. So you dry out the alcohol, and then you can put it in the car, and it will run. Petrol engines will run it. You might need to tune them slightly differently. In America, they mix they'll mix sort of 5% of it into petrol anyway, and there they tend to make it mostly by growing maize, which produces lots of starch. So like sweet corn, but sort of non-sweet versions of sweet corn, which produces lots and lots of starch. And then you can use enzymes to break that up, and then you can ferment it again and produce alcohol. The big problem is that sugarcane kind of works. You get significantly more energy out of growing sugarcane and fermenting it than you put in. But if you start growing maize and start putting fertilisers onto the soil, you start using diesel to drive your tractor around, and you move it about, it ends up using almost as much fossil fuels as you'd have used, if not sometimes more fossil fuels than you'd have used by just using petrol in the first place. So it's not quite as nice idea as it first appears.
OK, I hope that's answered your question. Now, Malk says, can we be totally sure that global warming is man-made, or could it just be happening naturally?
There are natural cycles. The sun does get slightly warmer and slightly cooler. There's a 11-year cycle and there's longer cycles, and that does affect the temperature of the Earth. But definitely pumping carbon dioxide into the atmosphere will make the Earth warmer. In the past, when you've got increases in carbon dioxide, the atmosphere of the world has got warmer. And the simple physics is that carbon dioxide insulates the Earth, so it will make it warmer. And pretty much the part of the warming could conceivably have been, in the last 50 years, could have been natural, but a good deal of it is definitely human-made, and if we carry on going the rate we're going, absolutely definitely it will be.
It's Mike who's wondering, with all the talk of pyramids and things, how do mirages work?
Okay, mirages are an interesting effect. Normally, it's you're going around in the desert, and suddenly you're looking down and you see something which looks like water. You actually get them on hot roads in Britain as well. And the reason why you see them is the same reason why things look distorted through a piece of glass. In glass, light goes slower than it does through air, and if it hits it at an angle, it will bend slightly. And that's the reason why if you look through a glass, everything looks slightly distorted. Now, if you have on a day where the sun's beating down really, really fast and the air near the ground gets very, very hot, that means it expands. Actually, light will go slightly faster through hot air than through cold air. And above that, you've still got some quite cool air. That sets up so that light coming slightly downwards from the sky will get slowly bent upwards into your eye. And that bending upwards means that when you look downwards, you can actually see a bit of the sky on the ground. And the sky, so it looks like a reflection. And you think the normal thing which reflects light is a puddle or water. And so you immediately think it's water. You get the same thing on very hot roads. If you ever notice the hot road looking slightly shimmery when the sun's low on a hot sunny day, that's the same effect. The hot air goes faster, it bends the light, and you're seeing the sky in the road, and so it looks all shimmery and light.
All right, time for a few more questions now. Hidera in Linton says, should we be filtering our drinking water? Is it safe to do so or not? Or is it just an unnecessary expense? And what are we filtering it for?
I'm not an expert on this at all. The filters will certainly remove things like the hardness, so the calcium in the water. And so the water coming out, which will be a lot softer, and some people definitely like making tea with softer water, so they take the calcium carbonate out of the water. Definitely some filters will do that. They also are said to remove things like any pesticide residues in the water, and other things, and some of them might be able to take nitrate. I'd be surprised if they could take nitrate out. I don't know. I couldn't tell you whether it's needed or not.
Clutching at straws, Dave.
Yeah,
that's okay. Mark in Bletchley says, I wonder if you could ask Dave, how much of the coastline is eroded each year in metres or yards?
It depends where you are. If you're in East Anglia, bits of East Anglia, Norfolk coast, you can get several inches a year. Some places, if you got particularly, of course, these things have to average over a long time, because one year you'll get a big landslip and it'll take 10 metres away all at once. But I think some places are losing up to a metre a year, probably a bit, maybe half a metre a year. Other places where you've got these have got cliffs which are basically made out of glacial mud. So during the last ice age, the ice sheets came down from Norway and Scotland, and they ground up lots of rock underneath them, and they ended up finishing somewhere in this area. And as they finished, they melted all of the rock and mud which they'd picked up, has got dropped out, and has made most of East Anglia, having the surface of East Anglia and the Norfolk Cliffs, which means that they're not very hard. They're very easy to wash away because a pile of mud isn't very good at resisting the sea. Whereas if you've got a cliff made out of granite, it could be eroding at millimetres a year.
All right, well, one last email from John, who says, with the Arctic thawing out, what effects will this have on the ocean levels? And is the same thing happening in Antarctic? Must I go and have some swimming lessons before it's too late?
The Arctic itself melting isn't a major issue because the ice is floating. And if you've got ice floating and it melts, it doesn't actually. If you've got ice cube in your drink and the drink is full, and as it melts, it won't actually change the volume of the water. Yeah, you'll get a slight change in volume because the water in other places are warming up, and hot water expands if it's above 4 degrees centigrade. As it gets hotter, it expands, so it will take up slightly more space. But the big problem is ice on the land, which is melting. So things like glaciers and ice sheets, especially in Antarctica, but also the Greenland ice sheet. If the Greenland ice sheet melts, it would increase the sea level, I think, by at least a metre. If Antarctica melts, quite many metres. So that's a much bigger effect. All
right, for the last then, mankind wants its cake and eats it. We want power but use short-term answers. No one wants a wind farm near them or nuclear power stations near them. If mankind was to get a grip and turn to wind, etc., how many wind turbines would we need to supply the country? Mark Storman.
Each wind turbine, big ones produce about 3 megawatts. The UK, I think, needs at least 90 gigawatts. So that's about at least 30,000. But wind turbines, you probably need to treble that because on average, wind turbines only produce about a third of that power. So you'd probably need at least 90, 100,000 of them. I know David McKay worked out you'd have to cover the whole of the British coast with at least 3 kilometres deep of wind turbines to produce enough power to run our lifestyle.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.